The objective of this tutorial is to introduce the new features added to the Ranger Neo's web server tool. First, if your meter has been acquired with the DAB/DAB+ option or the Advanced FM option, you can now see the related advanced measurements in the Measurements and Spectrum area when tuning a DAB/DAB+ channel or FM carrier respectively. We will tune a DAB channel first, and indeed, all the advanced measurements are shown in the right. Similarly, when tuning an FM carrier, we can see the advanced measurements as well. Secondly, if we move to the monitoring area, we can see that now we find two monitoring options: signal quality monitoring and spectrum monitoring. Signal quality monitoring is the same monitoring mode we introduced previously in our earlier web server tutorial, with the major improvement being that now we can configure pre-alarms and alarms for all those advanced measurements for FM and DAB/DAB+ signals. We can see this in the monitoring task I created previously. For this FM carrier at 99 MHz, we can see that it is possible to set up alarms for the MPX deviation, left plus right deviation, left minus right deviation, left deviation, right deviation, pilot deviation, RDS deviation, and the offset. For DAB/DAB+ channels, we can set up alarms as well for advanced measurements such as the FIB ratio, MSC CBR, and the FIC BER. Obviously, all these measurements are stored in the meter after the monitoring task is launched and while it keeps running. Once we launch the monitoring task, we find two new fields that inform us of the currently running time for the active monitoring task, and another that informs of how many measuring loops have been performed over the channel plan linked to that task. The second monitoring option, called spectrum monitoring, will allow us to continuously monitor the spectrum trace, looking for drops and overs in the spectrum bandwidth under inspection. We will create a new one so that you can see the whole process from the start. First, we will name the task. Select the measuring units for the signal level or power level, the timing between sweeps. Every sweep will be stored in the internal drive, and the input to be monitored. In this case, we only have one input available, but with the 8RF and 16RF input options for the PROWATCH Neo models, you could have either 8 or even 16 inputs to choose from here. We can set up as well the email where all notifications and alarms will be sent to. The next step is to set up a name and the type of detection we want to perform over each input. During this tutorial video, we will focus particularly on the first type of detection, called FM and meant to monitor FM carriers. To do so, we need to capture an initial spectrum trace that will be used as a reference mask to compare our received signal with thereafter. Once the FM detection type is selected, a new set of fields shows up that let us fine-tune how the monitoring will be done. The max threshold will define the minimum signal level of an FM carrier to be included as part of our reference mask during the reference capturing process, and as well the signal level to be surpassed for a new carrier to be considered as an over or newly discovered carrier. The minimum threshold will define the signal level value which a previously captured or detected carrier should drop under to be considered a drop. Reiteration defines the number of consecutive spectrum sweeps during which these conditions should endure in order for carriers to be considered overs or drops respectively. Start and end frequencies set up the specific frequency bandwidth that will be monitored, and reference level will set the reference level set on the analyzer during the whole process. Average count sets the amount of averaging used in the spectrum displayed. Resolution filter and video filter set the values for the resolution and video filters used. We can now press the Acquire References button. We will be displayed the spectrum mask acquired and the carriers that have been identified according to the parameters defined previously. Every carrier identified is tagged with a black point. On the right, we can see the list of FM stations identified and their frequencies. We can now adjust again the reference acquisition parameters if we are not satisfied with this mask, or once we are, save the monitoring task and launch it. Anytime there is a drop or over, we will be notified on screen, and an alarm will be generated and notified by email. During the monitoring process, all new alarms are listed below the live spectrum display. Under this spectrum monitoring mode, the instrument could monitor all RF inputs sequentially in case there was more than one. However, we must remember that all inputs must be then in the same band, either all in terrestrial, from 5 to 1000 MHz, or all in satellite L-band, from 950 to 2500 MHz, while using this monitoring mode. While the signal monitoring is ongoing, we can access to the historical monitoring area and export the stored data in CSV format for the input and time frame selected. In the Table tab, we can see events that have happened within that time frame. When we double-click over one specific event, the Graph tab will be displayed so that we can see the spectrum trace status at that very moment. And we can move back or ahead in time, pressing the left and right arrows respectively, which will show us previous and subsequent traces for that specific event. Finally, the Task Planner has been updated in order to include the scheduling of spectrum monitoring tasks. Now it is possible to schedule the meter to run a monitoring process, signal quality or spectrum monitoring, a data logger, a screen capture, or a transport stream recording. Each task must be assigned with a time frame for it to run, duration of execution, and frequency of repetition during that time frame. Several tasks can be created in this area.